Welcome back to a new video lecture, and in this lecture we discuss a new topic, and it is related with the estimation of RCC retaining wall. Actually, what do you mean by this retaining wall, or what is the purpose of this retaining wall? Actually, it is a structure which is designed to resist the lateral pressure of soil. So here you can observe that a retaining wall is constructed with concrete and steel reinforcements. So our aim is to calculate the quantity of this concrete and also this reinforcement required for this particular construction. So here you can observe that this part is called the stem and this bottom portion which is called as base slab. Okay, and the length of the wall, it is called this one. Up to this much length, it is called the length of wall. And while we taking the analysis or estimation part, we will observe this diagram only. Okay, this cross section or this elevation view only we will take. Okay, so here this one, the reinforcements are provided in this way, and here vertical reinforcements are also here. So we have to calculate all those horizontal and vertical reinforcement, that is main bars and distribution bars. Okay, so now we move on to our today's problem. So first of all, you have to understand what all the bars are given and what do you mean by curtailments, then what about the stems likewise. So here you can observe that already I mentioned this one is called the stem portion and the bottom portion is called the base slab. And if you observe, there is a distribution bar with 14 mm dia, 25 cm center to center spacing. And then you can observe that the main bar and its diameter is going to be 22 mm dia and its center to center spacing is going to be 40 cm. So here you can observe that this main bar is placed at a distance of 40 cm and a curtailment is provided here, means some bars are only up to 3.8 meter and this bar it is going to be 6 meters and another bar it is going to be 1.8 meter only. So the height is going to be cut out at this particular range, that is 3.80, and in this case the center to center distance is given as 40 centimeter, and here if you observe this distance is also given as this one and this one, it is also given as 40 centimeter. And when you are coming to this third case, that is 1.80, its height is or its distance it is going to be 20 centimeter only. And if you observe, there is the top portion, the breadth it is going to be 20 centimeter and the total length of this or breadth of this width of this base slab it is on 300 centimeters. So here you can observe this is 75 centimeter, here 165. So if you take it is going to be 60 centimeter. Okay, so we need to calculate in the left. If you observe the left side, there is also distribution bars and vertical bars, and here also distribution bars and the main bars are also provided. So we need to calculate all those values. Okay, so and before going to the calculation part, the total length of the wall it is going to be given as 30 meter, and the clear cover at stem top and both sides it is going to be 50 mm. So if you observe the top portion it is going to be 50 mm and in this side also the cover it is provided as 50 mm, and a clear cover at the bottom portion it is given as 70 mm, here 70 mm, and a clear cover at the both sides it is going to be 50 mm. So that's a given data. Okay, so clear cover is provided. So our first aim is to calculate the concrete required for that. The first case, that is slab. And if you observe the total length of the slab, it is going to be given as total length of the wall 30 meter. And the breadth it is given as, if you are taking the breadth already mentioned, the 300 centimeters. So if you write in meter, it is going to be 3 meter. Then the height of the slab, it is going to be 0.5. So you can write down. So a quantity LBH. So if you multiply 45 meter cube. Then coming to the stem portion, the total height up to this stem it is going to be 6 meter. You can observe here, length of the wall it is 30 meter, and you are going to take the average of the breadth. So if you take here, it is going to be 60 and here it is 20. So 0.2 plus 0.6 by 2. It's the unit, all the units are in meter. So 0.2 plus 0.6 by 2, 0.4 it is going to come. So if you multiply, it is going to be 72 meter cube, and if you add up those values is 170 meter cube. Okay, so that is the RCC work, 1:2:4 ratio for the slab and the stem. Okay, so now we move on to the reinforcement cases, different reinforcement cases. So here you can observe that we start from the right side, and the steel bar including bending, 22 mm dia main bars, and at 40 centimeter center to center spacing. So you are going to consider this one main bar with the diameter 22 mm. So we need to calculate the total length of the bar. The total length of the bar. So here you can observe, actually these bars are provided in vertical throughout the retaining wall. Okay, these main bars are provided in a vertical position throughout the throughout the wall. So here you can observe that we need to calculate the total length of this particular length. The one case, what is the total length? So here you can observe that the total length you can calculate from 6 plus 0.5, you get 6.5, that length minus top cover. If you are taking this 6 meter, the top cover is also included, and if you are taking this 50 centimeter, this bottom cover is also included. So you have to reduce those values, that is minus top cover and bottom cover. Then you have to add this hook values, that is 2 multiplied by 9d, the diameter of the particular bar. Then there is a small statement here, a 0.75 meter. You can clearly observe from this diagram, a 75 centimeter is provided here. So you have to add this value also. Actually, we are taking this length from this hook portion to this way and up to this much. You are going to take the values. Okay. So if you observe the total value, it is going to be 7.53 meter. And our next aim is to calculate the total number of bars. Total number of bars is required for particular maintenance of this retaining wall. So here you can observe that the total length of the wall it is going to be 30 meter. Total length of the wall it is going to be 30 meter, and we have to reduce the clear cover from both the sides. There will be a clear cover, so you have to reduce that clear cover. So it will be 30 minus 0.1 means 50 mm to each side. Okay, so if you convert them into meter, it is going to be 50 plus 50, it is going to be 100 and 100 mm. Okay, so if you take in meter 0.1, so 30 minus 0.1 divided by 0.4, the center to center spacing, plus 1, and you will get 76, and then multiply with the 76 with this value, you will get the total quantity required, that is 572.28 meter. Then coming to the next case, that is the main bar itself, and the length is going to be up to 3.8 meter. The same procedures are repeated here also. So here you can observe that the total length it is going to be, we know that the total length we already got that 7.53, and our aim is to reduce these values. Our aim is to reduce those values. So here you can observe that 7.53 minus actually 6 minus 3.8. 6 minus 3.8. Actually, we are reducing this much values. Okay, 6 minus 3.8 means we are reducing this much values. Our aim is to consider only up to this much values. Okay, from this there will be a hook is provided and we have to find out up to this much. Okay, so the same procedure is repeating here also. So now we move on to the next case, that is to the 22 mm dia main bars, that is up to 3.8 meter. So if you observe that our aim is to calculate up to this much portion reinforcement. Okay, so we already know that the total length it is going to be 7.53, we already obtained, and so we have to reduce this much portion. For that you are taking this 6 minus 3.8. If you reduce this much values, you will get 5.33 meter. Okay, the remaining portion, this much value, it is going to be 5.3 meter. And then you can calculate the total number of bars by the equation, that is the bars are arranged in this way, and we know that there will be clear cover at the both the sides, and also we are providing this bars 20 centimeter to this side, and here also 20 centimeter to this side. There will be a clear cover. That also you have to, that is not actually clear cover. The distance you have to provide, the distance which you have to provide. So 20 centimeter to both the sides. So you will get, if you add up those values of 50 centimeter and 50 centimeter you will get, and 0.5 if you reduce and divide by 0.4, the center to center spacing plus 1, you will get 75, and if you multiply with these values, 399.75 meter. Okay, so the last case, that is up to 1.8 meter. The same procedure is repeating here also. The length is going to be 7.53, and we have to reduce this much distance. Okay, our aim it is to calculate up to this much only. So you will get 3.33 meter, and the same procedure is repeated here also. You can observe that 30 minus 0.3, actually clear cover, it is going to be clear cover both sides is 5, and if you observe here, the distance from this side it is going to be 10, and here also 10, so you have to reduce that also, and you will get 30 centimeter, and 0.3 meter divided by 0.2 the spacing plus 1, you will get 150. Okay, so if you multiply these values, you will get 499.50 meter. Okay, and next you have to calculate the total length of the bars. Total length of the bars is from 3 cases. If you add up, you will get 1471.53 meter. And if you are taking the weight, the d square by 162, you will get 2.99 kilogram per meter. If you multiply these both values, you will get the quantity, that is 4399.87 kilogram. Okay. Then coming to the next case regarding the distribution bar with the 14 mm diameter, and the center to center spacing it is given as 25 centimeter. So here the total length it is going to be, so this one is going to be the distribution bar. Okay, so the distribution bars are provided in this way. So here you can observe that there will be bending and overlapping. Actually this total length it is going to be provided as 12 meter. So actually the total length of the wall it is going to be 30 meter. So the minimum length which, or the maximum length which we are going to provide is 12 meter, and so there will be overlapping. Okay, if you connect this way only, you can achieve this 30 meter. Okay, once again I'll repeat, you have to provide this way the bars to be provided connected to each other. Okay, then only the bars will reach, and there you use the equation, that is length, that is 30, and a clear cover, so you have to reduce the clear cover at both the sides. Then the overlapping at two joints, assuming here in this case we are only assuming two joints overlap, it is going to be 40 multiplied by d. So if you use d means the diameter, and 6 multiplied by 9d. Okay, why we are taking this 6? There will be 6 hooks are there, 1 2, then 3, and this one 4, and this one 5, and this one 6, likewise. Okay, so if you add up those values, you'll get 31.78. And to calculate the numbers, how many distribution bars are there, so you can take the total height, it is going to be 6 plus 0.5, 6.5. Then you have to subtract these both values, okay, this top and bottom. So you will get, and divide by the center, this center to center spacing by 0.25 plus 1, you will get 27. Then 27 multiplied by 31.78, you will get 858.06 meter. Now we move on to the next case, that is the 14 mm diameter main bar, center to center spacing is 30 centimeters. So here you can observe that bar, and it is also provided vertically. So the same equations which we already used, you can use here also. So total length it is going to be 6 meter plus this 0.5, that is 50 centimeter, 6.5. Then the clear cover at the top portion and this bottom portion you have to reduce, and you have to add this hook length also. Both the sides there will be hook is provided, so you have to add that hook also, and you will get 6.63 meter. And the total number it is going to be, total length of the bar it is going to be, total length of the retaining wall it is going to be 30 meter. So the clear cover, if you reduce, it is going to be 30 minus 0.1 divided by the center to center spacing plus 1, and you will get 101. And 101 multiplied by 6.63, you will get this value. Okay, and after that, you have to calculate the total length of 14 mm diameter wall bars. So here you can observe this one, it is going to be 40 mm diameter, and here 14 mm. So if you add up those values, you will get 1527.69 meter. And the diameter, if you take 1 d square by 162, you will get 1.121. This d represent the diameter, and if you multiply these values, 1.21 multiplied by this value, you will get 1848.51 kilogram. Okay, and now we move on to the next case, that is 10 mm diameter distribution bars at 30 centimeters. So here you can observe that bar, and here also we use the same equation, and you will get the same value, that is the total length it is going to be 30 meter. Reduce the clear cover from both the sides, then the overlaps you have to add up. The diameter is different from the previous case, and there will be 2 hooks, 6 hooks will be there. So in this way it is provided. Okay, in this way 2 overlaps will be here. Okay, actual length it is going to be this much only. That's why we are connecting to make this 30 meter. Okay, and if you add up those values, you will get 31.24 meter. And the total numbers you can calculate by using 6.5 is the total length, and you have to reduce the top cover and the bottom cover, and you will get 12 centimeter or 0.12 meter, and divided by the center to center spacing, that is 0.3 plus 1, you will get 23. Multiply 23 with this value, you will get 718.52 meter. And then coming to the next case, that is the base slab, and here also the 10 mm diameter bar at 25. So here if you observe this 10 mm diameter distribution bar, if you observe, you can see that, and its center to center spacing is 25 centimeter. So here you can observe that this 0.75 plus this 0.6, then So coming to the next case, that is the base slab. Here also you can observe the distribution bars are provided, these dotted portions that represent the distribution bars, and its diameter is 10 mm, and center to center spacing is given as 25 centimeter. Okay, so the length will be same. Here also the distribution bars are provided, so the same length here also you will get the same equation you can use. And the total numbers you can obtain by 0.75. Actually this much length, it is going to be 0.75, then 0.6 meter, then the remaining it is going to be 0.3, and you can reduce the clear cover from the one side, this side only the clear cover, so you get more clarity from the first diagram. So here you can observe that 75 centimeter plus, then the remaining distance it is going to be 60 centimeter, then the remaining distance 30 centimeter, and you have to reduce the clear cover from this side. Okay, this side you have to reduce the clear cover from this side. Okay, so then divide by 0.25 plus 1, you will get 8 numbers. Then if you multiply this value, you will get 249.92 meter. And coming to the next case, here you can observe the 10 mm diameter distribution bar at the bottom heel portion. And here also the length it is going to be distribution bars are provided. Heel portions you can observe the total numbers you can calculate, that 1.65 and this 0.6. Okay, 1.65 plus 0.6 minus the clear cover from this side, divided by 0.2 means the center to center spacing, and you will get 12, and multiply with these values, you will get 374.88 meter. And after that, the total length of 10 mm diameter bars, if you add up, you will get 1343.32 meter. And you can get the weight by d square by 162, you will get 0.62, and if you multiply this value, you will get 832.86 kilogram. Then coming to the next case, you can observe that we are providing 16 mm diameter main bar at the bottom. Here you can observe that 16 mm diameter main bar, and the length you can observe that we will move on to the first diagram, that is 0.75 plus 0.6 plus 0.3 minus this 0.05 plus this hook distance. Okay, you will get 1.89 meter. So moving on to the diagram once again. So here you can observe that the main bar and its diameter is going to be, its diameter is going to be 16 mm, and if you observe the total length is going to be 75 centimeter plus 0.6, then 0.3, then you have to reduce this side, and also you have to add this hook to hook side also, then only you will get the total length of the bar. So if you observe here, you will get 1.89 meter, and you can reduce this value 30 minus 0.1 divided by the 0.15, that is the center to center spacing, you will get 201, and if you multiply 201 with this 1.89, you will get 379.89 meter. Then coming to the last case, that is 16 mm diameter, here also a main bar is provided, so you will get the same equations you can use, that is at the heel portion you can observe this 165 centimeter plus, then the remaining it will be 0.6, then you can reduce this side, and you have to add this value, this hook values. Okay, once again repeat, this 165, we are calculating this main bar with this 16 mm diameter, 165 plus this 60 plus, then you have to reduce this side, then the hook also you have to add 2 hooks, 290. Okay, so you'll get 2.49 meter, and you can easily calculate the numbers also, that is 30 minus 0.1 divided by 0.1 plus 1, you will get 300. Then 300 multiplied to 2.49, you will get 747 meter. Then the total length of 16 mm diameter bars is going to be 1000 to 6.89. Then weight, it is going to be d square by 162. If you apply, you will get this 1.58 kilogram per meter. Then you have to multiply these values, you will get this. And the total weight of all steel bars is, if you add up all the values which you have calculated, and you will finally get 88.62 Kindle or 8861.73 kilogram. Okay. So I hope the section is clear, and with this we wind up today's section. Thank you.